Imagine standing on a beach, watching a ship sail toward the horizon. As expected, it gets smaller and smaller. But then something impossible happens. The ship doesn't just shrink, it begins accelerating away from you, moving faster and faster, even though its engines haven't changed. The ocean itself is stretching, pulling the ship away at an ever-increasing speed. This isn't happening on Earth's oceans, but it is happening in the cosmos right now. Every galaxy beyond our local neighborhood is racing away from us, and that race is speeding up. The universe isn't just expanding, it's expanding faster and faster, driven by the most mysterious force we've ever encountered, dark energy. Welcome to the story of how we discovered that our universe has a one-way ticket to an increasingly lonely future. In 1998, two teams of astronomers were hunting for the universe's fate. They wanted to know, would cosmic expansion eventually slow down and reverse, causing a big crunch? Or would it coast forever at a steady rate? They studied Type 1a supernovae, exploding white dwarf stars that act as cosmic lighthouses. These stellar explosions are remarkably consistent in brightness, making them perfect standard candles for measuring vast distances. The plan was simple. Observe supernovae in distant galaxies, measure how fast those galaxies are moving away from us, and calculate whether expansion is slowing down. But when the data came in, both teams found something nobody expected. The distant supernovae were dimmer than predicted, meaning they were farther away than they should be. Galaxies weren't slowing down at all, they were speeding up. It was as if you threw a ball into the air, and instead of gravity pulling it back down, it shot upward faster and faster. The discovery was so shocking that both teams checked and rechecked their calculations for months. Saul Perlmutter, Brian Schmidt, and Adam Rees led these teams, and their finding was so revolutionary they won the Nobel Prize in Physics in 2011. They had discovered that roughly 5 billion years ago, the universe's expansion shifted from decelerating to accelerating, and it's been picking up speed ever since. But this raised an even bigger question. What force could possibly overpower gravity across the entire cosmos? Scientists gave this mysterious force a name, dark energy. And dark is appropriate because we know almost nothing about it. We can't see it, we can't detect it directly, and we don't know what it's made of. We only know it exists because of what it does. It pushes space itself apart. Here's what makes dark energy so strange. It fills all of space uniformly. Unlike matter that clumps together into stars and galaxies, dark energy appears to be spread evenly throughout the universe. And as the universe expands and creates more space, there's more dark energy. The total amount increases. Think of it this way. If you have a room filled with air and you make the room bigger, the air spreads out and becomes less dense. But if that room were filled with dark energy instead, making it bigger would create more dark energy, not just spread out the existing amount. It's as if empty space itself has energy built into its very fabric. The numbers are staggering. Current measurements suggest that dark energy makes up about 68% of everything in the universe. Regular matter, all the stars, planets, gas clouds, you, me, accounts for only about 5%. The remaining 27% is dark matter, another mysterious substance we can't see directly. This means we literally don't understand what 95% of the universe is made of. The leading theory is that dark energy is the energy of empty space itself, what physicists call vacuum energy, or the cosmological constant. Einstein actually proposed something like this over a century ago, but called it his greatest blunder when he thought the universe was static. Turns out he might have been right all along, just for different reasons. So, what does accelerating expansion mean for the universe's future? In the short term, And by short, I mean the next few billion years, not much changes locally. Gravity still holds galaxies, solar systems, and planets together. Our Milky Way will even collide and merge with the Andromeda Galaxy in about 4 billion years, because the gravitational attraction between nearby galaxies is strong enough to overcome expansion at local scales. But zoom out to the cosmic scale, and the picture grows increasingly isolated. Galaxies beyond our local group are already moving away from us. In the distant future, these galaxies will recede so fast that their light can never reach us. They'll cross beyond what's called our cosmic event horizon. The universe won't actually be getting smaller, but our observable universe, the part we can see, will shrink. Eventually, trillions of years from now, astronomers in the Milky Way, if any exist, will look up at a night sky containing only the merged remnants of our local galaxy cluster. Every other galaxy will have raced beyond visibility. They'll see a universe that appears static, small, and lonely, with no evidence of the Big Bang or cosmic expansion. They might never know what we know today. And it gets more extreme. Some models suggest that if dark energy continues to strengthen, we could face a big rip where expansion eventually becomes so powerful that it tears apart galaxies, then solar systems, then planets, then atoms themselves. Other models suggest a gentler but still bleak heat death, where the universe becomes cold, dark, and empty. We live in a remarkable moment in cosmic history, a time when the universe is old enough that we can see its past in distant galaxies, yet young enough that we can still observe the evidence of its birth. We're here at just the right time to piece together this story. The accelerating expansion powered by dark energy reminds us that the universe is stranger and more dynamic than we imagined. We're sailing through an ocean of space that's not just vast, it's growing beneath us, carrying us toward an uncertain but fascinating destiny. And somewhere out there in the darkness, accounting for most of reality itself, is a force we've barely begun to understand. That's not a problem to be feared. It's an invitation to keep exploring, keep questioning, and keep marveling at just how extraordinary our cosmos truly is.